Hello, everyone. This is Professor Tina Burns, and I am happy to be back with you guys. This is Lecture 3A for the summer session of CS211, which is computer architecture. All right, so we're going to go over a couple things today. The main thing we're going to go over is kind of GDB, and also we're going to look at debugging some code. We'll save that assembly level processing for the next lecture. All right, so let's look at what GNU Radio is, and let's kind of go over some basics. Now, GNU Radio actually stands for, I'm sorry, GDB, excuse me, stands for the GNU Radio Project Debugger. And we use it because it really helps us as we go through kind of this debugging process in C. Up to this point, what we did for using debugging was kind of like this very kind of approach where it was just like hard coded, where we're just going in and we are manually trying to like a brute force method, trying to determine where those errors are. And it might have ended up involved doing some print screens and all that. But the GNU Radio Debugger provides a tool where we can kind of step by step through the process that helps us to easily diagnose our code and hopefully improve and figure out what's going on with it. Now, the way that we activate this is by adding a -G in our compiler command. So we're already used to using this as our part of our makefile in our compiler. And what we do is when you have that GCC-G, this thing right here, basically this flag is something that will allow you to debug your code. Now, what you want to also notice is that because it has this input name here, this is going to be your C file and your output file is going to be here, which is your executable, which means that your debugger can only work with an executable file that is for the compiler to understand. Now, the way that we access GDB is just by typing in GDB and then whatever GDB alone will go ahead and open up a window for you. But if you want to look specifically at the executable, you just type in the name in the command line. All right, so let's look at what GNU Radio is. GNU Radio is this open source toolkit that allows us to process signal blocks. Now, its primary function is actually to simulate or to create kind of this platform for software-defined radios. Just as a note, I actually used GNU Radio for my dissertation. In WinLab, what I did was I took a bunch of software-defined radios and I sent signals back and forth and determined how accurately I could read from that using neural networks. So this platform was actually really useful, really great for debugging, and also for generating those radio signals. Now, the radio system simulation is really helpful in computer architecture or in communications. But with this platform, they created something called a debugger tool. And this debugger tool has some really key features that help us overall, right? One of the things that is really beneficial is that it helps us to represent a signal flow. Now, when you think of radios, right, you think of if you want to determine if you have a good communication source, you really need to look at the signals and very um, in a good amount of detail. And you want to make sure you can tell where the source and the sink is. You want to make sure that you can detect how that signal is being transmitted through your environment. You want to make sure you can see how it's being transmitted through certain mediums. So this is what that kind of platform and system was built for. In addition to that, the debugging tool really helps to look at that and look at the data that surrounds that. So it's really a really good good visual representation of signal flow. The other benefit is that it provides real-time data processing, right? So instead of me needing to wait for something to happen, what I can do is as these signals are going out and being sent, I can actually go in with this debugger tool and look at what's happening for various errors or various codes and really see what's happening either with my signal or with the data itself. Now, the debugger also allows you to create and establish kind of these breakpoints that can be used for data analysis. And it's really good for interpreting error messages. So since we know these basics, when we look at the interface, we want to talk about a little bit about signal flow visualization, real-time monitoring, diagnosing data flow. Those are pretty much the three main points, right? Now, as we use this debugger, what are kind of the common techniques, right? So I said before, when we were diagnosing the issues with our code, one of the ways you could do it if you're using brute force is you just keep on running it, then you go back and update it. You can run and add, excuse me, you can add print commands that will allow you to kind of see what's going on at each portion of the code. But that's a little bit of a elongated process because that means every time you want to monitor something, you have to come out of the code, stop the code, and then create another executable, update it, and create another executable, right? So that really is not necessarily the most efficient debugging technique. With the GNU Radio debugger, what you can do is you can, if you're working with radios, you can check those signals and the block connections while you're right inside the software. And the same thing applies to whatever your program is doing. You can put in breakpoints and you can pause the execution of a program. So now if I can put in breakpoints and say, I suspect that the error in my code is at a position, a particular point, what I can do is I don't need to stop the code and then rewrite it and put a print thing right there. What I can do instead is just set up this breakpoint so I know that once I get to that particular action, I can then do further diagnosis and analysis. And with the debugger tool, you can actually monitor variables in real time and see what their values are and how they're changing, right? Which makes it a whole lot easier for you determining when or why a certain program might not be outputting the signal that you expect. Now, GNU Radio is also going to show some error messages similar to what we see in the compiler, right? We use that GCC compiler to make it, and we see it tells us, hey, you have these particular errors. You're going to see a lot a similar fashion here with the debugger, whereas GCC is going to show you the errors in your C code. Your debugger is going to show you the errors that is associated with your particular output code or your compiled version of your code. So this is kind of our window for a GDB. This is what it will look like if I were to go to a regular Linux window and just type in GDB. And as a matter of fact, I am going to go ahead and do that. So in case you guys are wondering what is happening here, let me go ahead and clear this. So instead of using I know I was using Notepad++ before, and I also use Apache um, for the guacamole to log into iLabs. But today, what I'm going to use, and I may use this going forward, is I'm just going to SSH into the iLab computers. Mobile Xterm, which is this program I'm using right here. It's a free software. It's pretty good. I've been using it for years. And what you can do is you can set up it to remember a particular iLabs login. Let's say I wanted to log into iLabs 1. You put in your username and password. Oh, that's not what I wanted to do. Let me go ahead and rename that. So I mistakenly renamed that. Let me go back and take it back and name it where it was. Rename session. Okay, now let's see if we can log into this. Let's just start it from the beginning, right? It's usually not this difficult. I had some issues there. All right, there we go. So now you'll see I just added the it's gonna ask me for my password. I'm gonna go ahead and enter that in. Actually, I'm gonna probably have to re-enter that. I don't think I put it in right. All right, now what I can do is you'll see I had these sessions saved here already. If you use mobile Xterm, it gives you the option to save it so that now if I were to close this session out and log back in, well, first of all, now I'm on the iLabs machine, and once you SSH in, you'll see kind of this any messages and stuff that it wants to give you, but this is my platform. If I were to go in and then let me close this out. Man, I don't know why everything is kind of slow today. It's just me. If I were to open another session and just type in my username, it will automatically log me in because it remembers my password from the previous times that I logged in. All right, I'm gonna close that tab. I'm gonna close that tab. All right, all right, so right now I'm actually in iLabs 2, just because I prefer working in that one. If I were to type in this GDB command, you'll see that it comes up with this window here. And what this is, it's just your platform for operating GDB. Similar to if you were to type in Python, it would open this IDE or a server for you to work in Python. GDB is a command set or a thing that is inherently on the iLabs computers, and also in a lot of Linux-based systems. All right, so that is how we access it, right? So that's going to be part one. Let's talk about a little bit of some of the commands that we'll see. So when you're working with GDB, just like you would have with any other program or language, there's going to be kind of shortcuts that you can use to get to different things, right? A common command that you might want to use is as you're going through and you're parsing through code, you might want to go through next, which will go and execute the next line of code. There's something where you can just say run or R. So you have the command itself, and then you have the abbreviation, right? If you do not feel like typing out the entire thing, you can just do the abbreviation as a shortcut, and it will operate that same command. Um, that you would normally have. B is then where you can set your breakpoints, especially if you're looking for a particular thing in code. Um, C will allow you to continue running the program until you get to the next breakpoint. That means if I have something that is at line 73 and I want to run it, you can go ahead and run that from that line and then continue until you reach your next breakpoint, which might be at line 100. P, that's self-explanatory, or print. You're gonna print the specified variable, and then of course you can do Q to exit out of the program. Now, what's interesting here, this feature right here is this watch command, where you can use that to actually monitor a variable so that every time it changes, it will print out to the screen. So let's go ahead and start using this functionality to look at some of our code and see what we're expecting in terms of the input and output. All right, so let's say I'm gonna move this down a little bit because I'm not ready for that yet. Let's see where I am. All right, so let's get into our proper folder. Um, CS211, and we're gonna go into week 3. All right. All right, so we have our make file in here already. Um, let's generate a new file. We'll call this GDB test. Let's see. All right. So here's a C code. We're going to do, of course, is include our libraries. And again, I am using this to generate code for us to use for debugging purposes. Okay, so we have that. Let's go ahead and make our main function here. Oh, I was wondering why it was blue. Main function. Okay, now that I have my main function, what I want to do is we're going to set up our return. All right. Let's say I want to I have my main function here. I'm going to create another thing that will uh have a factorial. So we're going to say this is what this code is going to do. Um and we'll say this is a program that's going to calculate your factorial. Let's go ahead and run that. Let's go ahead and open up. Oh, you know what? We don't have our make file. I'm going to rearrange the screens just a little bit. All right, we're going to open that up and we're calling this GDB test. Let's go ahead and save that file. All right, now we're back at our main window. Let's go ahead and make this and make sure that it executes. Okay, I am not logged in there, so I'm going to get rid of that window or all right, so CD teaching. Now the bad thing about this is that each time you open this window, you have to open up another navigate to the tab, but I guess that's fine. All right. So now I've made it. It has this GDB test. Let's go ahead and run it. All right. So boom, our program, that first part is operational. let's say we want to just generate this factorial program here, right? So I know that I'm going to return some sort of factorial. I'm going to start off with I'll call this calculate factorial, right? Now, I'm going to input into this a number, and I know I'm going to need a for loop. Int I is equal to 0 to I is less than n, and we're going to basically increment that. And all we're going to do is we're going to return, we're going to keep on doing this until we return a particular value that we want. Okay, that's not what I wanted to do. So let's set up our initial value. We're just going to set that to 0. All right. So what I want the program to do is just calculate this factorial. Is that what you're going to have is that each time you run this is going to be equal to whatever your previous value was, and we'll initiate that at 0. It's going to be equal to val times 1. All right, so, and what I want to return here is my value. All right, so what I'm going to do is we're going to run this program, and this is our main function. We're going to go ahead and receive input from the user. So we're going to set up a integer for we'll call this A, and that's going to be equal to we'll just set that up as an A. We're going to get this in, scan into that so we have the actual value. And we'll print out, please enter your value for your factorial. Okay. And we will go ahead and end that, of course, with a new line character. We're going to enter that in, and then we will um we're going to go ahead and run the calculate factorial program here with the value of A. And why don't we also just print this value? Hmm. In A, and we'll also set up another integer down here. In F for factorial. And then F, since we're returning that, we're going to go ahead and make that equal to the calculation here. Let's try to make this and see kind of what we get at. All right, bunch of error codes here. Let's start with the first one. I thought I did put a... Oh, I did not end that with a... Also thought I ended that one with the semicolon. Did not look like it. All right. Oh, and then I did not finish this line here. Print F. Um, oh, you know what? I'm not going to do the print function here. I'm actually going to do it a little bit later. We're going to get the factory here, and I'm going to try to print it out from this other portion. And we'll say the factorial of um percent sign D is, and then we will go ahead and end that with a new line character. And let's go ahead and make this F or A and F. Those are our two variables there. Let's save this. We will make this file here. And we'll try to go to the beginning to find our values. Let's go ahead and clear this out. Okay. Um, oh, I'm not sure why I have it as an N there. This should be capital. And again, because the scanf is going to be expecting some sort of text character, our actual format for this should be percent sign %D. And I'm going to scan that into the memory address of this guy. All right, and then let's make sure we have our name and everything spelled right here. Now, cool thing with Nano is you can actually just have it set up to do to automatically copy the function name in that you have highlighted. All right, so now that should be, and I did that by just highlighting that and then right clicking. All right, so now that we have that, all right, so this program has now successfully ran through our bugs and we the compilation errors, and we have this what we believe is going to be a factorial. It's not going to calculate it correctly. I already know that. So I intentionally left an error in there so that we can see what happens as we kind of parse through the code, right? But anyway, we've created this into this what we call an output, right? Let's go ahead and run it. We're going to enter a factorial of 3. Now, notice how it says, hey, the factorial of 3 is 0. That's clearly not right. Now, we could go back and just troubleshoot the program by doing this brute force method. But why don't we use GDB since this is this amazing tool that we just talked about? So what I'll do is I'm going to exit out of that. Right, remember I said one of the commands you can use to exit it, excuse me, is exit. Um, and let's go ahead and start running this GDB tool. Now, if you guys remember from the slides, and I will pull them up again. Maybe I might pull them up again. Okay, yes, I will. Awesome. Anytime we want to execute it, all we have to do is type in GDB with a period and forward slash, and then whatever your executable name is. All right. All right. Now we are in. You see how previously when we opened this window, it did not have this information about the executable. Now it has it. So we're ready to go. We're ready to go and start kind of executing this and looking at where we are in terms of portions of code. All right, so let's go ahead and now that we have our we're in this GDB window, in this debugger, let's go ahead and start using this puppy, right? So the first thing you want to do is let's see what we have as far as commands. You can easily see a list of the commands by just typing in this help menu, right? And you can see the general commands here. Now, if you want to get a little bit more specific, you can type in a command for each of those, excuse me, for each of these things in order to get more support. I kind of know what I want to do here. So I want to start out by looking at the source code. Actually, let me make sure this is right. So help layout tells me that I can look at either the assembly code, I can look at the, I don't know what TUI is, but it's something. And you could also look at the source code in your layout. So let's see, let's go ahead and do that. All right, so I just typed out layout source, and what you'll see is it will give me uh all of my source code that I just wrote here, so I can easily trace back and be able to debug it and determine, what line of code am I seeing my error or seeing the items in, right? All right, so that's my first portion, and we already know if we want to run the code, we can simply type in run. And then you'll see that just like we were in the terminal, it gives us this command or it gives us the output so we can run it. Let's type in our number. All right, it does give us an output, right? The factorial of 3 is 0. However, it comes up with this error. Now, this error is associated with just a couple of variables and things that need to be changed when we compile it. So what I'm actually going to do is I'm going to go back to our previous window. Before, when we compiled it, we used this and we compiled it using um, just the -G. But if you add another command in here, so let's go to GCC -G. I believe it's -O0. I believe that this will get rid of that error. So we're going to put in our compile it. This is the first flag. I want to use GNU Radio. The second flag tells me that I am going to kind of get rid of some of those errors that I'm seeing there in Linux. And then I'm going to need my file name here, -C. And then the output that I want to put this to is -out. All right, that did compile it. Let's just make sure that we can operate it. And it does, in fact, execute. All right, so let's go back to that window. So again, there's some special permissions and different things going on in Linux that sometimes you want to make sure that when you compile it, and maybe you want to keep that in mind when you compile it, in your make file, you might want to just add this -0, at -O0. In fact, I am going to add that here just so I remember the next time. All right. My question is, was this a capital or lowercase? I guess it was a capital. All right. Here's a code. We don't need that. Back to GNU Radio. All right. So now I'm going to go to back in my window. And let's try to exit this again. Let's get out of here since we have now recompiled that. Let's open this again. We're gonna do layout source just so we can see our source code. All right, once we open up and we see our source code, what we can do from there is let's go ahead and run it. I'm going to use a shortcut command now because I want to save time. And if you'll see that it got rid of the main errors there. I'll still see this one, but I'm just going to let that one go for now. All right, now once I have executed that, I want to do something a little bit different. Let's set up a breakpoint. Okay, so this is how you cycle through the code, right? At the top of here, I can see where my code is. I already saw that I am not getting the value that I want to get, so I want to determine why am I not getting that value. And logically, I would say, hey, where is this actually occurring? So it looks like my main function is outputting the information, right? It asks the user for the input. I can scan in the data. I'm assuming I'm scanning in the data. And then I get to this portion where we're supposed to be calculating the factorial. So what I can do then is let me see what happens if I put a breakpoint at line 5. Now you can do it by either the line number or you can do it by the identifier. Like I could say break at calculate factorial, but I don't want to do that. So I'm just going to do it by the line number. All right, now we're going to run it. And now it does execute that first line, right? Which tells me to enter in a number. But notice that now it stops and it shows me that, hey, I am now stopping right here at this first breakpoint, right? This is where I'm breaking the code. And now that I have that breakpoint there, I can use that to my advantage because what I can do is I can set up now. I want to see what these values are, right? So let me set up a watch point for the value here. All right, so now I have this watch point for val of 2, and let me also set up a watch point for my integer value. Oh, okay. So the error that you're getting here is saying that it does not see this symbol because whatever watch point you're setting it up at, it has to be along or within that same line of code. So let's just go to the next line of code, which is here, and then we can set up our watch point. All right, so now I have a watch point at both for the variable val and also for the variable I. Now let's go ahead and run that next one. Okay, so let's look at it what it just did, right? It just did, it's giving me this value of I. It's telling me this is my watch point, and then it says, hey, this is your watch point. Your old value was this. It just sets a random or sets it up at whatever the memory address is, and then the new value is 0. All right, the old value is 0. Now keep in mind, this is my I. So the old value is 0, and now the new value is 1. What that basically means is that now I can see that, hey, my I value is in fact incrementing. If I run it again, old value is 1, next value is 2, and so on, right? It's going to keep on doing that, incrementing those values, and then it's going to update it as such. Now, what it's going to do here is it's supposed to be returning whatever my val is there. And we'll see that from that, we still didn't get the value that we wanted. So the question is, why didn't we get that value? All right, so I tried monitoring it in this for loop, and I saw that my I was in fact incrementing. Let's go through the loop one more time. And this time, let's try to watch and look at the value val here when we're inside of our for loop. So at line 9. Now I'm going to go back. I'm just going to refer to the notes just briefly so I can bring to my remembrance. some of the general commands I talked about. Okay. So I want to skip past the previous breakpoints that we had and set up another breakpoint at line 9. Okay. So let's go ahead and run this again. We'll run it from the beginning. The breakpoint is at calculate factorial. We'll go to the next one. Goes to that next line. Then we have val. Hmm. And now it's going to print out your data that you're anticipating, right? So it went through and um executed that value. Now look at this other thing. We're also seeing that even here in that value, this is at 496. So the other question is, where did that even come from? All right, it prints out that factorial, and now we're pretty much done with that portion of it, right? So what did we see here? My other question is what happened here? Let's go back into that. All right, so from that, I was able to see that I was in fact incrementing. So I suspect that something is going on with our val setting here. Now, looking at my code, I can already see, or I already know, that this is pretty much going to be associated with, or it's going to be caused by the fact that I'm adding 1, or I'm just multiplying the initial value by 1. So what really needs to happen is I need to update that so that it's actually incrementing properly. So from that, from what we just did, I diagnosed that 1, this I in fact was incrementing. And the problem is in this line here. So let's actually go back. We're going to exit out of this code. We're going to go back. Let's update our main program and compile it again. Um, what I want to do is instead of just multiplying it by 1, my initial value was 1. Hmm. What I'm going to do is I'm going to multiply this by All right, so the first thing we'll notice is that every time, if I start my val at 0, every time it multiplies it, it's gonna go ahead and multiply this by 0. So instead of me starting at 0, why don't I just start this at 1? And what I'll do is then I started at 1 and I just multiply it by whatever the value is. Let's see what happens when we do that. We're gonna go ahead and compile this baby. All right, it is compiled. Let's run it. We'll put our value in and boom. All right. Now we get to say, hey, 3, the factorial of 3 is 1. Yes, we do know that that is not in fact true. So we can do to resolve that. And of course, we could go back and look at this with GDB, you might as well. Why not, right? All right, run. We'll put a break. We'll put a breakpoint at 8 now. All right, we will run the code. All right, we have this breakpoint at 8. Let's go ahead and watch Val. All right, and let's go ahead and do the next line. Next line. And next line. All right, so we got into the state again where it looks all kind of funny. I'm going to actually exit this. We're going to go back into this program. Okay, now we're back here. Let's set up our breakpoint at uh we set up it at line 5. We're going to run the program. We're going to enter the value that we want it to be. And now that we are at this line 5, it is now continued to line 6. We're actually going to watch the val here. So you remember before when we tried to observe the changes to val, we never saw it. And that's because the observation should be at the first place where the variable is declared. So now we're going to put this watch val here. We're going to run that. Oh, wrong command. We're actually going to do the next one. All right. And you'll see that it says, hey, this is my watch point. It's going to be val. Old value is this number, and the new value is 1. And notice how then it exits the program. Then it just continues with the next item. And that's once we get to the value where n is equals to 3. And then, of course, it's going to output what we expect the values to be. So we already see that val never ever actually got updated to this maximum value. And one of the other issues we see is that when we initially ran the loop, it did look like it ran 3 times, right? So let's go ahead and gonna let this run again. This time we're gonna run it. We're gonna set up the breakpoint at 5. We're gonna do a watching of our variable I. Oh, we should run it first. Enter in our value that you want to be. You want to watch it at I. So I just exited that. Let's go ahead and set a breakpoint. Let's set it a little bit early. We'll set it up at 4. We're gonna run the code, enter in our value, and then so we set it at the up at the breakpoint right before or attempted to, and it did not do that for some reason. All right, I believe that it set it up for the next line after. So since line 4 is actually a comment, it just went to the next line that precedes after 4. Um which would be the function for calculate factorial. But that is actually okay for what we need to do because we're just going to watch val. We're going to go to the next one. We're going to watch I. We're going to go to the next portion of code. So now we have two things. We have a watch point for value and for I. And we see that I, the value is 0. It changes to 1, changes to 2, and then it changes to 3. So we do in fact see that that is updating as we saw previously. All right, so given that, we still have the problem where val only updates to 1. All right. So what I'm going to do is I'm actually going to exit this program. It's going to tell us we have a process running, but that's fine. And let's go through and just fix the code. All right, we already know that we have we're expecting a particular value here. The initial problem is that we did not actually add the value of I. All we're adding is a value of 1. So once we change that to be actually I, then we should see this guy update as we expect. So now we save that, we will make it, and then we will execute it. That's interesting. Oh, okay. So this should be, I really I plus 1, or we start at 1 and then go to n plus 1 in order to make sure that we're incrementing correctly. And then there is kind of where we start to get the values that we are anticipating, right? 1 times 2 times 3 does in fact give you 6. All right, so that's just a kind of a basic overview for how we can use GDB to help us a little bit more with our troubleshooting. And you'll find it very useful as we go into assembly code. Actually, we can take a look at a portion of that now, because why not? So assembly code, you guys know it is kind of this interim language between your high level language, high level programming, and machine code. So if we wanted to easily see the assembly language, we can look at that here in C. So remember I said if we go to help layout, it'll give you a list of the commands that you want to see. So if you wanted to see the assembly code, we can type in this ASM here. And you'll see that it outputs this assembly code for us. Now, we'll talk a little bit more about this in the next upcoming class, but this is the assembly code for this program that we just completed, right? Looks a little bit more kind of more detailed than what you would normally see in C code, but it's because it has to write and read a bunch of operations and all that. So we'll talk about what this means the next time. Other than that, enjoy your day, guys, and I will see you later.